So this question 18. This one's a bit hard, so it's 6 marks. But you have to find a, b, and c, and they're given in these functions. So a, b, and c. So let's start. So in this question, you need to know that the only way you're going to be able to derive these values is through significant points, which are intercepts that are also intercepts that are legible, intercepts that you can actually read, because these ones directly cross over points like this, if you get what I mean. These directly cut these points, so you can actually tell where they are. And also this one, because this directly cuts through these two grid intercepts. This doesn't look like it, but I can guarantee that it does, because I could prove it later on, but I've done the question before. So, but this is just assumed because that cuts through these two. So you need to get your significant points. So these two intercepts and this one are the only real significant points you can have. A section of the graphs of the two functions is shown. Determine the values of a, b, and c. Now, because a, b, and c are stored in g of x and f of x, let's just rewrite them to just get a head around what the functions are. So f of x equals 3 log base 2 x plus a plus b, and g of x equals negative log base 3, so just note that they're both different logs, x plus c plus 5. Now, g of x is more clear, you know what's going on more in g of x, so it'd be best to just get this function out of the way now. Now, so if you really want to find this function straight away and get c out of the way, because it's probably going to be the most easiest one to determine, try and get a g of x unique point, which would probably be this intercept here, because it doesn't consider f of x at all. It doesn't consider f of x, and it's one of the main points. So let's just erase this to get a feel of where it's at. So this point right here is at, so it's at x equals 0, so 0, but it's at y equals 5, so 5. So just write down here, g of x, y intercept at 0, 5. So now that this is a valid point, so you know that the graph does cross through this, you can say that when x equals 0, it's equal to 5. Because it's the same form as if you take g of x and you think of it as y, it's kind of like y equals blah 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 blah. But you have your x in this function, and you also have your y here. So it's just blah, 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 but you have your x and your y. So g of x is equal to your y. So you know what the y-intercept is at this. So you know that g of x equals 5, but it's at x equals 0, if that makes sense. So 5 equals, and then just sub in g, but then make x equal 0. So negative log base 3, makes x equals 0, plus c, plus 5. With this, so you can just simplify the function a bit, negative log base 3c, because it's just 0 plus c, it's just c, plus 5. Let's just subtract 5 from each, minus 5 from each side. So then you end up with these cancelling and these cancelling, so you end up with 0 equals negative log base 3c. Now you can put this negative on this side, so it just turns into negative 0, or just 0, so you're kind of just cancelling it. 0 equals log base 3c. Now you can make both of these to the power of 3 to cancel the log base 3, so let's go 3 and 3, because log base a and then whatever, so let's just do c in here for example. If you have this but have it to so a to the power of log base a, this log base a and a cancel, and you end up with just c. So a to the log base a c is just equal to c, because these both cancel, and this is what it equals. So now you can just cancel this log base 3, cancel this 3, and you get 3 to the power of 0 equals, because c comes down, c. Anything to the 0 power is 1, so c equals 1. So that's your first. Now, you get a bit of working out for this question, because it's quite a big question, it's worth 6 marks, so let's just rewrite g of x. So now let's go to an arrow, therefore g of x is equal to negative log base 3, so we're just rewriting the function from up here, but subbing in c, x plus 1 plus 5. Okay, now that you know that, that makes things a lot easier, because c is constant, it does not change. So now let's go back up and let's go start working on the next page, because we've used up this page. So now we've kind of used this point, and now there are 2 other points you need to consider, this one and this one, because they're what we can derive values from. Now, so this intercept point here, you must know, at intersections between 2 functions, they equal each other. So now, knowing that, so we know that they equal each other at this point, so we can just go, hence, f of x is equal to g of x. Now knowing that, so we know our new g of x. So let's just put f of x and g of x on. So let's just sub both of these functions into here. So f of x is equal to 3 log base 2 x plus a plus b, which you don't know yet. So that is equal to g of x, which is equal to negative log base 3. And remember, c is equal to 1, so it's x plus 1, because we found that earlier, plus 5. Now they equal each other at this point. But you also need to remember that because we have x's that we can play with here, we have x's here, if you actually look at the intersection, you can get the x from it, because the graph kind of gives you the x. Right? So if this is 5 here, this is going to be 1, 2, 3, 4, and this x is at 2. So you can sub x into both sides, which is 2, where they intersect. 3 log 2, 2 plus a plus b, equals negative log 3, 2 plus 1 plus 5. This entire side has no variables in it, so you can kind of just solve it. 3 log base 2, 2 plus a plus b equals negative log base 3, 2 plus 1 is 3, plus 5. Log base 3 to the 3, right here, sorry for that, log base 3 to the 3 is equal to 1, because, you know, log base a to the a always equals 1 if these are all the same thing, because they are. So you can go 3 log base 2, 2 plus a plus b equals negative 1 plus 5, which is equal to 4. I'm just going to swap the sides of these two. So I'm just going to put them on the opposite. So 4 equals 3 log base 2, 2 plus a plus b. Okay, now let's just make it so it all equals b. Because it's kind of hard, because we want it to equal a variable, because you know that you're going to have to use simultaneous equations in this. Because you're going to get an equation from using this point and this point here. So let's just let it all equal b. Okay, so you get, so let's put all of this on this side. It's just going to be a subtract, because this is a plus here, you're not going to divide, you're only going to subtract. So 4 minus 3 log base 2, 2 plus a equals b. Okay, now that we have a value for b, let's just leave this here. So, you know, b is equal to this. Right? So let's just put a little circle and a star next to it. Okay, now, at this point here, let's start working with that. Sorry, I accidentally did this. So let's just leave that there. Let's just remember this equation. Now, this point is, so f of x intersects the y-axis at this point, which is y equals 1. So remember, so let's just continue from here. At y-intercepts, x equals 0. But at that point there, so x is equal to 0, but y is equal to 1. So let's go f, x, usually you'd say f of x, but x is equal to 0, is equal to 1. Because if you sub x at that point, you get 1. So now let's sub in the entire f of x. So 1 equals, but make sure x is 0. So f of x, let's just use this equation here still. So 3 logs to the base 2. And x is 0, so 0 plus a plus b. So now that you've subbed that in, you can turn this into what, because you just simplify, so 1 equals 3 log base 2a plus b. And now you can do the same thing as earlier, because you have, see, you've made this equal b. Well, if you make this one equal b as well, if both of these functions are equal to b, the functions equal each other at that point. So now let's go b is equal to, so let's just do this step first. So 1, so let's just put this on this side. So 1 minus 3 log base 2a is equal to b. And now let's just flip this equation, because it's, actually no, let's just leave it like this. Now let's put a little star next to it. So these equal each other. So if we take just b is equal to b, right? B is the same thing. So now let's just sub these equations on either side. So for this one, this b is equal to this. So 4 minus 3 log base 2, 2 plus a is, so this function is equal to this function here. 1 minus 3 log base 2 a. Now let's just make it easier and get the logs on the same side. So let's make this go onto this side. So because it's subtract now, it will end up being plus. So negative 3 log base 2a, which is this one, plus this function, plus 3 log base 2 plus a. So you have 4 on this side, and positive 1 on this side. So let's just get this positive 1 and put it on this side of the equation. So you end up with positive 4 from this side, and then because this is positive 1, you'll make it minus 1. 4 minus 1 equals this. 4 minus 1 is 3, 3 equals negative 3 log base 2a plus 3 log base 2 plus a. And now there's 3 in both of these functions, so we can take the 3 out. So 3 equals, now let's just go 3, and then just divide 3 by both of these, because we've taken it out. So negative log base 2a plus log base 2 plus a. And then we can actually divide 3 by both sides, it's convenient. Which would cancel these, and make it equal 1, and cancel these, and just leave you with the rest of the function. So let's continue this up here. 1 equals, and with this, let's just put this minus after this one, so it just looks nicer. So log base 2 plus a, minus log base 2a, because we're just carrying the negative, right? So with log laws, you know that when you do log of a and then a function, let's call this f, minus log of a, and then let's just do another function, so g. This doesn't associate with the actual function, these are just examples. If you subtract the logs, you divide, say this turns to log base a, f divided by g. So let's just use the same concept here. Let's get rid of this, same concept here. Let's go 1 equals log base 2, because it's a subtract, so 2 plus a over a. And let's get rid of this log base 2 by raising both things to the second. Put both things on 2. So you get 2 to the 1 is equal to 2 to the log base 2, 2 plus a over a. But as said before, you can, if log base 2 and 2, they can cancel. This is why you raise it to the second power. So you can get rid of this log base 2. So you end up with 2 equals, and then this function, 2 plus a over a. Put a on this side, 2a, because you're just multiplying a both sides. And then these cancel, but then this equals 2a equals 2 plus a. You can put a on this side, but this is a plus, so you're minusing it, so 2a minus a would just equal a equals 2. So now you know what a equals. A is 2. Okay, now that we know that a is 2, let's just take any instance of when we've gotten a function for a. So let's just take this one for example. This function here. Because now that we know what a equals. Now let's bring this out here. I'm just going to start it on here, but you can use it on the continuation paper on the back of the booklet if you're solving it from there. So let's just get this, because we know what a is, so we can sub a in, now that we've developed that a is 2. So we can go 4 minus 3 log 2, 2 plus a is equal to b, so this is the function. But then we can sub 2 in as a. 4 minus 3 log base 2, 2 plus, and then a, which is 2, equals b. 4 minus 3 log base 2, simplify it, so 4 equals b. Now, with this, log base 2 to the 4, this is going to equal 2, because what you put into this, so if we put this into index form, you have your log base 2, so 2, and then when you do this to the power of your answer, it equals this, so 4. But you know that 2 to the power of 2 equals 4, so that is going to be your answer for this right here. So 4 minus 3, and log base 2 to the 4 is going to be equal to 2 equals b. 4 minus 3 times 2 is 6 equals b. b equals 4 minus 6, which is negative 2. Now that we've gotten the 3 values that the question asks for, a, b, and c, so at the end of your question you would go overall, because you found them, all 3 of them. A equals 2, comma, b equals negative 2, comma, and then what was c equal to? 1 over here. C is equal to 1. Underline your answer. So that's the question complete. A is equal to 2, b is equal to negative 2, c is equal to 1.